Hello guys, we will be talking about engineering drawing today. Uh, what is engineering drawing? Let's start from what is engineering drawing. Engineering drawing is a way of communicating engineering ideas, way of communicating engineering ideas or concepts or designs or simply designs. Okay, so why is this important? This is important because engineering drawing makes it standard, makes it clear, and makes it easy for the communication of engineering ideas, concepts, or drawing. So there are two ways of engineering drawing that are being practiced in the world right now. The very first way is the very conventional way we generate engineering drawing in terms of in paper, and we transfer the paper, and this paper helps in communicating designs. So this for this convention there are some standards, there are some conventions, okay, conventions and or standards or protocols, whatever you may say, for engineering drawings. Another way is CAD. We use the tools of CAD, tools of computerized system to generate CAD designs designs. So some things are common to both, and some they are different in some way. Let's talk about the fundamentals of drawing. For drawing in a paper, we are studying about drawing in a paper. We need a sheet, a sheet on which we can draw our engineering designs, our engineering drawings. So there is a standard sizes. Let's talk about the very size of the sheets. Okay, in the world, this is the standard convention of drawing sheet. We use a paper which dimension is 184 mm by 1189 mm. This size is termed as A0 or AO. This size of paper, when divided in half, creates A1. When this is divided in half, creates A2. This division in half creates A3 and A4. Similarly, this this line exactly divides the upper lines into half. So there are standard sizes of A0, A1, A2, A3, A4. Okay, let's talk about A0. Standard size, when area. When we multiply the 841, 0.841 times 1.189, it yields 1 meter square area. So A0 is a standard sheet of paper having 1 meter square area, but not the side length of 1 meter. It is a side length of 841 by 1189 mm. And another standard convention of this standard rule of this paper size is the smallest to largest length, largest or longer length. Largest length ratio is always equals to 1 is to root 2. So if we divide 184 by 1189, it will result in 1 by root 2. Okay, so it means 841 by 1189 is also equals to 1 by root 2. We can calculate it. This is the standard convention of sizes. Let's talk about borderline and margins. So this That was the standard size of paper. Let us take about borderline. So what is a borderline? So if this is the paper, we cannot just draw here. We have to take some margin, and we have to set the working area. This is the working area. This is known as borderline, and this gap is known as margin. This is top margin, this is bottom margin, this is right margin, and this is left margin. uh, of course, if we have multiple seats, we need to join the seats, and for joining the seats, there is the left margin is more in terms of length than other margins. Okay, so left margin is more, we have to remember this. uh, okay, this is borderline, this is working area, and for any drawing sheet we have a title block here. This is known as title block. Title block. So, uh, okay, we have talked about borderline, we have talked about margin. Let us take this seat as a standard A3 seats. Okay, we can take any standard, but for our ease, let's assume this is a A3. No, we have defined the size already. We have defined the borderline margin. We will use the title block. So, what is a title block? Title block is the descriptions of the drawings, who created it, who checked it, the company, the name of the firm, different detailings about the drawing. Okay, sorry. Position. Title block's position is right bottom. Right bottom. Okay, right bottom. In the title block, uh, the size of title block depends on size on paper, size of sheet, whether it is A3 or A4. This size determines the size of title block. Okay, next is our uh, DRN, CHK, and approved. So this in the title block, drawn by, checked by, approved by. The name and corresponding dates are mentioned for each person's. Okay, so we have to define projection. The how this drawing is made, if it is first angle or third angle. Projection. Another thing is, what is the number, what is the seat number, if you have multiple seats. Number, seat number. Tolerance finish, tolerance finish, surface finish, if there is anything. The name of the form and title of the drawing is also most important. Okay, so this is okay, we have to define scale also. So scale, we will talk about scales now. So form, name, title, these are the contents that are necessary for the title block. So what is scale? Let's talk about a very fine topic known as scaling. Scale. So in real life, the let's talk about building drawing. Building is very big. Okay, building is very big, and we cannot just accommodate the whole size of building into the sheet of paper. If we are drawing in A3, so we have to scale down the building. Okay, scale down means if it is of 100-meter height, we have to accommodate into let's say 100 mm. Okay, 100 mm. So this is the scaling down. Scaling down, and this is also known as reducing scale. scale. The standard convention of scaling is we have one number here and one is 2 and 2. This first number represents the scale of the drawing sheet. The second number represents the scale of the real system. Okay. For the reducing scale, the drawing sheet scale is less. One, let's assume 1 is to 1000. Okay, 100 is okay 1000. So it is more than 1000. This is the reducing scale because the sheet is less than real. Let's talk about a small part, microchip. So for the microchip, if we draw the microchip in our A3 paper, it will be very small. Its dimensions, its detailing cannot be exactly defined. So we have to scale up. So if we have the 10 mm long microchip, we can make it 100 mm. So this is known as enlarged scale. This we have enlarged it because our drawing sheets will be for this 10 is times greater than the real sheet. So it is in large scale. Okay, so we got that. uh, Third thing is we talk about reducing scale, we talk about enlarged scale, or reduce full scale. Third thing is full scale. Full scale means we draw in the same scale as in real, that is 1 is to 1. So if I draw the pin of 100 mm in the sheet of 100 mm, so it is a full scale drawing. There is another thing in scaling, this which is known as representation factor. Factor. What is representation factor? It is the length in drawing, length of anything like length of any side in drawing upon actual length. If you have a rectangular area, then area of rectangle in drawing upon actual area upon root 2, upon square root. Why is this in square root? Because the reducing factor or RF simply is generally represented in terms of ratio of length. Ratio of length. Okay, representation factor. So I think this is all for today. We'll continue with the types of line and types of projection for tomorrow.